Hi there, myself Madhav Jha. I welcome you to CodeChef and let's have a look at this question.
The problem is min-max DQ. This is the easy version of the problem. For this problem, there are no prerequisites. Let's have a read at the prompt. We need to consider an array A of length n, and n here is odd. Now, Alice and Bob will play a game on it. We will let B be the initial array and this will be empty. Now for this, Alice and Bob will take turns playing and Alice will play first. On the ith turn, the current player will choose the element AI and they can insert it into the empty array. They can either insert it at the beginning or at the end of the array B. Now so Alice will first place the element AI and then Bob will place the element AI plus 1, in this case A1 and A2. Then again Alice will place the element A3 and so on. This will continue until all the n elements have been placed in B. Once the game is finished, Alice's score will be defined as the minimum of the first and last element, in this case B1 and Bn. Now Alice's objective is to maximize her score while Bob's objective is to minimize Alice's score. We will define the function f of a to be the final score if both the players are playing the game optimally and starting the array at. So you are given an array of length n where n is odd. Now this portion is only required for the hard version, so we can ignore it for the easy one. So for the input format, we have t test cases, and for each test case, we'll have first two lines. The first line will contain the integer n and q. In this case, q will always be 0. You can read on about more the functionality of q in the harder version. So n will be length of our array A. Then on the second line, we'll have n spaced integers that will be a1, a2 till an. And for the output format, we'll simply need to output that what is the answer, a maximum one that Alice can get. For the constraints, we have t test cases that will go from 1 to 10 raised to 4. The value of n, that is length of the array, will go from 3 to 2 into 10 raised to 5 minus 1. Since n is always odd, it starts with 3 in this case. And the value of elements itself will go from 1 to n. Let's see some sample input. So for the first sample input, the length of the array given is 3. In the easy version, you can see that the second input here is always 0, so we are ignoring that. The array given to us is 1, 2 and 3. Now, first Alice will play, so Alice can fill the first number 1. Now since Bob is playing second, Bob will have to place 2 either at the front or either at the back. Let's assume Bob will place it at the end. Now, Alice can place the element 3 either at the end or at the start. Now, since Alice wants to maximize the score and we are taking minimum of the first and last element, it is in Alice's favor if you place 3 at the start. With this, the border elements, the first and last, are 2 and 3, and the minimum of them is 2, and as you can see, that's the answer here. Let's see how we can approach the solution. As we have seen, when we are starting the game, let's assume that we have these numbers 1, 2, 3, 4 and 5. At the start, the array B is always empty. So let's first play the 2 rounds because this will always be the case. 2 will always have to play. So we have 1 and 2 and these are the initial border elements. Now what will be Alice's strategy? We know that Alice will always play the last move. So when Alice is playing, she will try to eliminate whatever is the minimum number here with us. So in this case, the minimum number present is 1. Since we only want the border elements, anything that is not a border can never come up again. So whatever number Alice will have, Alice will try to eliminate the smaller number with that. So in this case, when we have 3, Alice will try to place it at the start. Now the border elements are 2 and 3 and Alice will take the minimum of them, that is 2. Now what happens if Bob comes to play? Now that Bob is playing, Bob will try to decrease or hinder Alice from getting the maximum score. So Bob's game would be to make sure that the maximum number that Alice has, he will try to make sure that it is not possible for her to take it. So in this case, 3 is the maximum element, but because we already have 4, right? If you place 4 after 2, Alice will get the win, right? Why? Because Alice will be able to maximize the value not by taking 2 but actually taking 3 if you put 4 at the end. So Bob will try to hinder the maximum element. So here Bob will place the 4 here now. When Alice takes the sum, in this case the minimum is still 2. Now Alice gets the last game. So again Alice will try to eliminate the smaller number. The smaller number here is 2. So Alice will play the last move and try to eliminate the minimum of these. In this case that was being 2. So now the border elements are 4 and 5. So Alice can take the minimum of them, that would be 4. So how can we use this to solve the problem? So we know that first two elements are already there. So we'll pick whatever is the maximum. Our initial answer will be nothing but the first two elements, 1 and 2, right? The first and second element. Now with this, when Alice is playing, Alice is trying to eliminate the minimum element that we have out of this. So whatever number we take, we'll try to replace the minimum with that, right? Alice will try to eliminate the minimum. Similarly, when Bob is playing, Bob will try to eliminate the maximum number. So Bob will take the maximum of the answer that we have and the element that they are given with. And at the end, whatever result remains with us will be our answer. So if we try to follow this case of 1, 2 and 3, we already have 1 and 2. Now Alice will try to replace the smallest element, that is 1. So Alice will take whatever the minimum and replace it. So what is our current element? Our current element would be 3. So since we took initially the max of this, that was 2, then we take the current element that we are going to receive, that is 3, we take the minimum of them and the answer would be 2. If we include it, in this case when we have 1, 2, 3, 4 and 5, then for the fourth element when Bob is playing, Bob will try to remove the maximum element. In this case that would be 3 and 2, right? So Bob will replace 3 and at the end when Alice again plays, Alice will try to replace the minimum element 5 and at the end Alice will be left with 4 here. So with this, a play of minimum and maximum will get our solution. Let's see how we can implement the solution in C++. So for each test case, we take the input of n and q. Q for this version of the problem is always 0, so we can ignore that. Then we take the element of input of n elements starting from the index 1 till n. And once we have that, we know that the first two boundary elements are 1 and 2. So we take the maximum of that. Then from the third element, what we do is, if it's Alice's turn, Alice will try to replace the smallest element. So we'll find the minimum of them and replace it with whatever current element that we have. Then if it's Bob's turn, Bob will try to replace the maximum element. So for that, we take whatever result we have and the current element and take the max out of it. At the end, we print the result. And as you can see, I've got an AC in my C++ implementation. Let's see how we can implement this in Python. Again, for each test case, we call the function solve, take the input of n and q. Then we take the input of our array. First, initialize the border elements as first and second. We take their maximum value. Then from the third, Alice will try to replace the minimum value and Bob will try to replace the maximum. At the end, whatever we are left with and a result, we print it, and as we can see, we have got an AC in the Python implementation as well. So I hope you understood the problem, the approach, and how we can implement the solution in both C++ and Python. Have a very good day, and I'll see you in the next.